we get started again. Everybody heads up, wake up. Woo, Woofy's in the air. Look out, Bill. That wins something, right?
That's a good shot.
I get a shirt for that. Good shirt for that. We got a fighting rotary. All right, next guy up. We're pretty much going to dive off the deep end now. It's going to get pretty geek. He's going to dissect TCP. We do 101 all the way up to like the 700 level, right? Something like that. We're just kidding completely. He's going to get pretty geeky on it. He's going to do some TCP dump stuff and some workspace management with Screen. If you guys are familiar with Screen, you will be after this is over. Got a nice little tenacity pack here. Who wants it? All right, your turn. Power cycle from the free world.
Hi, everybody. Hi. Yeah, so, all right, I'll just start real quick. All right, who am I? I used to be a security operations engineer at a distributed denial of service company. Basically, I wrote firewall rules to protect servers from botnet attacks. They could be UDP floods that range from anywhere to 3 gigs to 120 gigs distributed across the world. My nickname's PowerCycle, Twitter on PowerCycle, and Freenode, and stuff like that. I'm also a certified ethical hacker, and just passed that last year. The topic for today is tcpdump, which I really hope that when we get out of here in an hour, you really know how this works, so that not only for your defense, but just so you can analyze your own traffic and know what it is you're leaking or not leaking, like Adrian was going to talk about. The second part is going to be comparing tcpdump to tshark. And tshark is the command line version of wireshark. So if you install wireshark, you've automatically got tshark there. And then the third part's going to be the flood of information you can get, like what was passing on the screen at the beginning. How you can use Screen to manage that so that you don't fill up your hard drives, and you can easily search back and forth for stuff. Okay. So the top command up there, tcpdump-nni eth0, that's the simplest base command that you can use with tcpdump. The nn, first n, tells tcpdump to not resolve the IP addresses, so that when you're dumping on something, there will be a delay in DNS query and then display of that name. If it's a flood of information, you don't want to look up the host names. You want to display the information as quickly as possible, as raw as possible. And the other thing is, host names can be really, really long. IP addresses are pretty much the same, length, given 3 or 4, different, depending on some single characters, but it's pretty much very even. So it makes it much easier to look at. The second N tells tcpdump to just display the port numbers themselves. For instance, if you tell it to dump on port 80, it'll tell you that port 80 is HTTP, but the data that's coming in on that port may not really be HTTP, or it may not really be HTTP data. It could just be a flood of something else. It could be completely misconfigured, or it could be someone just trying to take you down. So what I like to do is I just like to look at the numbers. I don't want to resolve anything else, just pure numbers. Okay. Once you've got the interface that you're looking on, if you just run the first command, there will be everything that's going off of the interface. If your network's infected, if your box is infected, it's going to show up right there. Usually what you want to do, though, is you want to limit it to some degree. When I was working, I was at a span port that was open to me in a bunch of different data centers, and I could monitor 100 different clients who may be using 100 different domain names each. What I want to do is just pick out one IP in that stream and follow it. So the easy way to do it is just say, I want to watch tcpdump-nni-eth host, and then the IP address. You can also put in the domain name there if you want to, but I like numbers. To get more specific, you set the direction of the traffic that you want to watch. So the dest host 10.0.0.100. The reason is, if you're watching your own network or your own computer, and someone is attacking you or scanning you or something of that nature, you should already know what's inside your network. So the actual response data to any request is usually about 10 times greater than the size of the request itself. If you just go to the root of any regular domain name, you're going to make 4 or 5 calls, you're going to get images, you're going to make MySQL queries that flood data back to you. But for what I want to see is, a request has to come in first. So if you're trying to see if your network is infected and data is leaking out, you just swap it around and say source. So dest and source are the two opposing sides. Also with comparable to the host is you can say I want to watch a netbook. I would usually always watch /24s. Break it up into /26, 28, 30, things like that. It just didn't make any sense, so I'd watch 24s. With that, you can also specify just a protocol. So you can say, I only want to see TCP data. If you're on a network that is VoIP and has a lot of UDP traffic, and you don't want to look at that for right now, then you can specify and say, I know there's a flood out there, but just cut it down to just this. So the 3 important things are really the destination, the host, and the port. If you take everything that's going on your interface at ETH0, and then you figure out what IP address you want to watch, and then you figure out what port you want to watch, even if there's a whole flood, you can narrow it down to just a little bit of data, and that's the important part. So, does anybody get any questions at this point? Okay. Here what I want to show is -SO-A, capital A. -SO means that you want to look inside the packet. For these first commands, like if you just say tcpdump-nni-eth0, it's only going to show you the packet headers of what's going on. It's not going to be the data inside the packet. And it's actually the data inside the packet that's the really important part to determining whether it's malicious or valid or anything like that. So when you say S0, that's telling it I want the snap length to be 0. The snap length being how much do I want to look inside that? And 0 says I want to look at the entire packet. You can cut it down to 1, 2, 3 or whatever, but usually in those sort of cases, that's something you want Snort to do because you've already figured out a rule. You already know what you're looking for, you know it's only going to be so far down in the packet, and it can save you some processor time instead of going all the way to the end. For TCP dumping, when I'm just looking and I don't know what I'm looking for, I want to look at everything. The last command down here, which is like the 3 lines long, is what I want to kind of build up to, in that if someone comes to me and says something's wrong, I don't know what it is, the first thing I want to do is look at everything and then start narrowing it down and start analyzing whatever traffic I can see. If I just pull one packet out and follow that IP address and see whether he's valid or invalid, see what a successful call on the application looks like, I'll just pick that. But then, once I determine that, for instance, 10.0.0.100 is a valid client, then I'll just declare that I don't want to look at this traffic anymore. And for any other IP that's coming over my interface, I'll pick an IP and then just sit there and watch it and get to know the traffic. If it's VoIP traffic, how does it start up and how does it shut down? What other ports does this sole IP address open up once he makes a successful port or call on the first port, things like that. So as I start to analyze more and more traffic, like let's say at 10.20.20.0/24, let's say I'm protecting a server that's in the United States, and there is a whole lot of traffic coming off of this United States nearby net block. Say it's Roadrunner or something like that. And I analyze 1 or 2 IP addresses off of Roadrunner, and Roadrunner is just hammering it, and it's probably 1.5 gigs of the 8 gigs that are passing through. I'll just go ahead and ignore the whole net block. Even though there may be some infected bots inside that net block, there's so much good data that it's really hard to get a signature, so I'll just take that out because there's another 6 gigs to still look at. And I'll just say, okay, not this source net, and not this host, and not this net. So that all right, I'm just going to jump to this real quick. This is basically the theory and the idea of kind of what I just explained, that you want to start out by watching everything on the interface, and then you tell tcpdump what you don't want to see. And you peel back one layer at a time, one net block at a time, one port at a time, and one protocol at a time, until you have exactly what you're looking for, which should not be there. And it'll be the only thing left standing once you create a TCP dump string where you say, and not this source net, and not this IP, and not this port, and not this source net, and not this source net, and not this source net. I've built TCP dump strings that on my command line spanned 4 entire lines that just went on and on and on and on and on. Because if you make the assumption of I know what I want to look at and I only want to look at this port, you better be really sure that there is no other port to look at. If you're looking at a proxy server, your ports are going to be 80 and 443. It's going to be really simple. But if you're just analyzing it and someone says there's something wrong and we don't know why, there could be a UDP flood at port 53, which is preventing DNS getting off of the proxy server. It could be just anything. So you really want to start by looking at everything and just declare not this, not this, not this. Okay. So once you have been analyzing the traffic and you've narrowed down what you want to see, and someone like the president of the company or law enforcement has come in and said, we need some evidence. We know it's down, but why is it down? What proof can you give us to what's going on? That's when you want to report a PCAP. Especially in a case where you're working on remote boxes that are in other countries, across the oceans, in other data centers where you don't have a GUI interface. It's been my experience that most people talk about wireshark because of all the cool things it can do and because of the nice organization or color that you get to it. The problem is you can't run wireshark everywhere. You can run tcpdump anywhere. It is a really small program. The data that it outputs can be very, very big. Imagine you've got a 1 gig per second flood on an interface. Now imagine capturing 7 seconds of that flood. The way that you can kind of limit what's going on is to set a count, and that option is -C. So in here, what I'm saying is -VB is just going to say, tell me how many packets you've captured, but don't actually display any of the packets you're capturing while you're running. and then the C is 10,000. Then the SOA, which is going to open up all of the packets to be displayed, and then dash W is going to write to whatever that file name can be. File name doesn't have to be named PCAP, it can be anything, but that's how most readers expect it to be. And you can go on with the rest of your string, whatever that can be. When you start writing your PCAP file, there's no way to limit the size of the file that you're capturing. So in some cases, I might leave a TCP dump PCAP running for 24 hours just to catch anything that is on an interface that's not passing any traffic. And I want to satisfy myself that nothing's actually going on when I'm not here. You can just leave it running. When it hits that 10,000 mark, it's going to stop. There is no way for TCP dump to manage how big the file is going to be. Only the number of packets. There's no way to limit the size to say, stop when you get to 4 gigs. It just doesn't have a setting like that, because the packet size that you're analyzing can be huge, very small. Usually they're very small. Usually when you do a normal PCAP on a normal network, you'll wind up with, maybe a 100 meg file, maybe a couple 100 meg file. But if it's an attack situation, you wind up with gigabyte files. And those are just unwieldy, and nobody wants to look at those. And you're going to have so much data, you can't present 7 gigs to the president of the company and say, here's why it's down.
That's why I accidentally kicked it.
Okay. So, once you've written a PCAP, the -R option is how you can read from that file. Once you're reading a PCAP, you can also add your own filters to it, so that, let's say you capture 7 gigs of it. If you go back and say, okay, now only give me this port and this IP address, you can read a PCAP, put in your string, and then write out that PCAP so that you have the raw data consistent, so that someone else can come in and run tcpdump or run wireshark, and they've still got that raw data. If you output tcpdump to a text file, that's not the raw data that can be read from another PCAP reader. Make sense? So a lot of times, a lot of people will put the greater than sign for the direction to just output it to text. And it's fine if what you want to do is email it to someone and say, look, your port really is open. You need to shut it down. Here's a quick 5 lines to show you how I telnet it into your past your firewall. But if you want, like I said, if it's for police and it's for evidence, they're going to want it as a PCAP, because they're going to want a lot of people to analyze the same thing that you looked at to make sure that it's really there. And if it's a text file, you could have just typed it in. Not to say that a PCAP is secure in any means, but it's data that can be read by many different things and analyzed. That's what it is. Okay, this is the part about TCP that you was talking about earlier, about explaining TCP. This is what a push packet looks like on port 80. This is just an example of what, if you went to the HackerCon domain, you'd be making one request to root, and this is what your browser is sending to the server to get the information back. TCP is a connection state protocol, so you've got 3 setup packets. You've got the send packet that's coming in, the send ACK that goes in the response, and the ACK, and then you send a push. So basically, there are 3 packets of data that don't really mean anything to you if you're going to analyze what the data inside the push packet is. after the push packet, you're going to have 4 packets that go back and forth to close the session. Your fin, your finac, your fin, finac. The important part is that even when you narrow it down to one host and one port and one protocol, there's still a bunch of data that you don't even need to look at if you're just looking for stuff. So what I really want to show you is right here, where it's got that colon, space, P, space. That, in that top line there, is what tells you, if you were to just look at a packet, this is a push packet. And the reason I love tcpdump is because this is a really compact way to display information. On the first line, I got a timestamp. I've got the source IP address, the source port. I got the destination IP address, the destination port. That is a push packet, the active window size, which aren't that important now. But the next line is telling me that it was the method get, what they got, and then the headers that were pushed in that information. So, and this is kind of the advanced part of it. Once you understand what you've got and what you're getting, if at the end of a tcpdump string, you just pipe that to grep, and then -I for include, and you put in quotes, colon space, P space, quotes, and use the -A9. That's going to tell grep that anytime you come up with colon space P, give me the next 9 lines down, which are basically going to be the HTML headers that are included in the push packet. And it's grep is only going to give you those 9. If it's a little more, then it's going to give you more in the stream, so you'll pick up the next packet. So it isn't something you really want to script and say, okay, I found a signature and I want to use tcpdump and grep to do it off of. But you want to find the information. So what I'm trying to show you is you can even cut down the flood that you get to just the data information that's being sent. Okay, so I feel like I went through that really quick, but I want to tell you about T-Shark and the difference between them. This is a T-Shark push packet. This is a tcpdump push packet. And this is limited to just that stuff. So the question is, if you're looking at 8 gigs per second, and you've got to look at 39 lines or 12 lines, which one do you want to use? How many people talk more about wireshark than tcpdump? How many people have ever used tcpdump for more than an hour? You know?
Does it count if you just let it sit there and dump the file, and then you go back and later on grab it and use it in a different tool?
Like wireshark.
Okay, in that case, yeah.
Whatever works. But the point being, the T-Shark output, like if you look at the top, it tells you, here's the source IP address. The next line tells you, here's the destination IP address. The next line tells you, here's the source port, the destination port. And basically this was really good if you're going to be reading the data out from another program. If you've got, if you're regexing for request method, then you'll come up with get, and you can feed that information into something else. If you're running a program that needs to sort through the information really quick. If you're doing it by eye, and you're in screen, you're looking at 8 gigs of data, or you're looking at 8 gigs of data on a 1 gig interface, I want to combine it and make it as simple and as small as possible. So, okay. So the other thing that I need to tell you is I'm not totally bagging on T-Shark. It has a very, very, very big advantage that TCP does not have, and that is in decrypting SSL. To give you some history, tcpdump is the program that's written on the libpcap library. The libpcap library is also the basis for wireshark, so they basically do the same thing. Wireshark is I guess a fourth, you would say, of what tcpdump was, everything that they did, and then they added to it. So what they added to it was a completely different layout for some of the information, but also the ability to read a PEM file and extract a certain key, and then be able to decrypt port 443 traffic that would normally be encrypted. So let's say I'm on a span port in front of a server, and I don't have physical access to the server, and I don't have, at the moment, I don't have access to the cert and the key. I can watch all of the traffic and every single packet that comes across and record it perfectly into a PCAP file. Later, if I can get the PEM file, which is the cert and the key combined, if I can get the PEM file from the client or whoever, all you have to do is read your PCAP in T-Shark and then tell it with the SSL key list, that line there, and where it has example.pem. That would be where you would say, okay, here's the certain key that I want to use to decrypt this crap traffic that I couldn't read earlier. And then with again with -w, you can just write it back out again, and you can read that PCAP in tcpdump if you want. You can read it in T-Shark again, or wireshark, or whatever. Any questions before I go to screen? Okay. All right. Here's a simple question. Who has used Screen before? Okay.
And only because you told me about it.
All right. Screen is what's called a terminal multiplexer. When you attach a session to a Unix box, you're given a TTY session, which is a virtual form of what used to be a physical teletype machine attachment to a local box. So what Screen does is it manages your TTY sessions for you on the box itself, so that, for instance, if I were to come up and pull the plug, your session, your TTY session, would die. Any programs you might have running at the time I pulled the plug are going to die. So for instance, if I were trying to let a PCAP run for 24 hours, I don't need to be connected to that server for 24 hours. If I run Screen, then run the program inside Screen, I can detach, and Screen will keep the program running because the TTY session is connected to the Screen. That's why it's called a terminal multiplexer. You can have up to about 24 different sessions inside the same Screen session and have no problems at all. Screen, most people don't even realize, has been default in all Unix installs since about 1978 or something. It's in FreeBSD, NetBSD, it's in every version of Linux, it's in Mac OS, it's on Mac servers, it's in anything that you installated. It's just part of the GNU install. Let me show you Screen real quick. So down here at the bottom, this is basically how you can keep track of how many sessions you have going on. You can give them different names so you can remember them, different whatever. And then down at the bottom, it doesn't really show up on this projector, but it gives you the name, because I have a hard status line set, it gives you the name of the screen that you're looking at. So inside one terminal session, you can have many, many terminal sessions operating. Instead of having to make a desktop full of screens all going at the same time, you just put them inside one thing. If you detach, if the wireless connection drops and you're inside a VPN that connects to your company and there's some other problem or any problem at all, if at any time the connection drops, the screen will take over and just sit there waiting for you to reattach to it. So one of the things that's really confusing with screen for people is that when you start screen, it doesn't look like anything happens. If you have a Mac and you just run the command screen, it'll flash and then you'll have a prompt. There's nothing on the screen to give you any indication that there's anything there, because there's no screen or docked screen RC file. This is the config file for you running screen on that box. It's saved in your home directory. So these are the important commands that I think you need to first manage screen itself, but then also manage the flood of data you get from a TCP dump. So I'll go through a couple of them real quick. But default UTF-8 is important if you run anything like Finch or anything that uses ANSI lines in their drawing. And then the second line up there is probably the most important that you need to understand. And that's escape /ZZ. In screen, the default command sequence is to hit Control-A, and then, for instance, N will take you to the next screen. Control-A, N will take you to the next screen. Control-A, P will take you to the previous screen. Control-A is also, in Unix, go to the beginning of the line. So if you're running TCP dump and you've got a line that's 5 lines long, very often you want to jump to the beginning of the line and go again. So the first thing I do in every screen is reset the commands. And since screen basically does the same thing as background, and I really hated it when I accidentally hit background of the program that I did with background, I made that the new key sequence. So that in my slides, it's going to say Control-A, and in every tutorial you read about screen, it's going to say Control-A, because that is the default since the 70s, that's the command. But understand, the first thing almost everybody does is map to something else. And I'll go down real quick. Turn the startup message off. You can give the session a name so that you can run multiple screen sessions. Like I've needed to record evidence for somebody for something, so I set up a session of screen outside my normal session just so that I could log into a bunch of different data centers and start PCAPs in all of those, and then know they were going to be running for 24 hours and I wasn't going to come back and check on them. So I just detach, leave that session running, and go back to my normal work session where I had my other 16 windows open. The -H command, that sets the history buffer for the window that you're looking at. So earlier I had several windows listed up there. When you're watching TCP dump, you're going to go to flood of data. You're going to see something, but by the time you can react to it, it's already going to be gone. So you're going to have to escape out of it and go back into what is the screen buffer. The normal screen buffer, I believe, is 1,000 lines, which for normal analysis is fine, but you can set it to a huge number, like 10,000 lines. That's more than 100 page views back in a scroll history. So that key thing also of setting a really big history buffer makes it easy when you find something, you're like, oh, what was that? You can go back, you can go to where you saw it, and then you can search again to see how long ago was it that this happened. This command came through that shouldn't have come through. In the last 10,000 lines, how many times have I seen this command come in? So it's really, using the two together is what I like to do. The -T option just gives a name to the window that you're looking at. So I like to have, I like to set in my Windows 0, I like to tell myself what the control character is for the screen session I'm running. Because quite often I run screen, and then on one of those windows I'll go to another box where I have screen running on that box as well. And you can stack screen sessions quite easily. All you have to do is set a different control character in each of those sessions. If you have the same control character and it's Control A, then you're only going to get the first screen that you're on. It's not going to pass through to the other screens. A couple other last things, like one where it says example.com 9 SSH power cycle add example.com. Inside your screen RC file, what I would do is I would set up sessions for myself. I knew I automatically wanted to have at least six windows open every time I started up. So some of those sessions would SSH out to other boxes that I always connected to every single day. If you put the number in there, like 9 or 8 or whatever, you can declare what window I want example.com to be on. By default, screen just goes to the next number. If you have 3 windows open, you say create a screen, it gives you 4. Inside the RC file, you can say 9 is going to go here. I'm going to have the first ones just open up in succession. Because they open up in succession, it's always going to be 0, 1, 9, 8, 5, 3, 4. Then the last important here is dash capital L. It's also possible in screen for, let's say for instance, you're working on a OpenWRT router, which I love playing around with. Those routers have very, very little memory in them. You can install tcpdump, but you can't save a PCAP on that router because the flash is not big enough. I can set a history file, which is going to be 1,000 lines long, and I could output that later to a text file maybe if I really, really want to show somebody what went on. Or I can use dash capital L and have screen log everything that goes to the screen for that particular window. So if the screen is running on a box that has a big hard drive, and tcpdump is running on a box that has a very little hard drive, and you need to save the data. You can't get the PCAP, but at least you can get the data. And you can have screen do it for you automatically. Or if you want to record someone and say, look, I want you to log into this box, have screen start up right then, and the screen will log everything that goes back and forth in the terminal session. Okay. The last one, hard status line, always on. Like I said, by default, when you run screen, it just flashes and then gives you another blank screen. You have to declare hard status line on. It's a really simple thing to do, but what screen is trying to do is not get in the way of any other program at all. Not until you actually turn on some of these options does the data kind of make sense, or you can kind of keep track of how many screens are open, how many windows are open, and where you're looking at without having to constantly say, who am I, and hostname. The hard status string there, I don't expect anybody to really remember it, but if you Google screen hard status string, you'll find a lot of different options where people have gone through and kind of made up specialty custom things. A couple of things that you can do is you can monitor the memory, you can monitor the CPU usage, you can basically take any stat that you can pull off the box, you can narrow it down to a couple of characters, you can throw it in your status line and screen. I don't really do that, but it's pretty cool to be able to monitor something right there without having to flip out to something else. And the last one is multi-user on. And this is kind of another one of my little tricks. By default, a screen session is limited to the user account that started that session, and only one session can be attached, or only one login can be attached to that session. By declaring multi-user on, you can log into the same box twice and attach two different terminals to that session. So let me demonstrate what that is. So if you look here, I've got two different terminal programs running at the same time. On the left, if you look down the bottom, you see it says Delta is the name of that screen. If you look over here on the right-hand side, in the bottom half of that screen, it says Delta also. These top two. But the idea being that sometimes I want to split screen, sometimes I leave a TCP dump running, and I may split the screen and split the screen until I've only got about 3 lines actually visible in there. And I may leave it as blank space so that if anything comes across, then I can switch to that screen itself, scroll back in a 10,000 line buffer and see what just flew by. By taking the two terminal sessions and basically vertically splitting the screen there, I can just add more and more data. My only problem, the one thing I wish Screen did that it doesn't do, is it won't do a vertical split. So it kind of expects you to only split it horizontally. If you use multi-user, then you can have 4 at the same time. You can just keep going. As many screens as you have open, you can put them all in there. For me, since I do all my work on the command line anyway, I don't want to have, one terminal session per screen. I want to have 2. I want to have 4. I want to have 8. And I'm not the type of person that flips from one desktop to the other desktop to the other desktop. I want to have a desktop that never changes, and then I just split and add and remove information as I want to look at it. So for screen, here are some of the important commands. As I said, Control A, if you read a tutorial on screen, that's what it's going to say the command character is. And what I changed it to in my first one is Control Z. I use Control R for my second one. I use Control Y for a third session. There's basically, you can use anything you want, but you have to be careful not to overwrite some other command that you're going to use on your bash command line or in Vim or something like that. But real quick, if you want to see what windows you have open, it's just Control A colon. That'll bring up the list. Control A N, next, P is previous. Another cool thing is if you've got a screen running on a lot of different things and you run something and it crashes, you can just kill only that window without killing the rest of the screen. The screen's very, very good at not dying. I've had screen sessions up for more than 3 months at a time that ran every day that I detached from, but I never killed them. I just left them running. I had windows inside those things die because the connection died or something like that, but you don't really have to restart the screen. It's almost as stable as the server itself is. If you want to, for instance, jump to window 3, you would just do Control A and then that number. It's really helpful when you've got like 18 windows open at one time. And then capital S is how you split. When you split, it just divides it in half. When you split again, it takes that and divides it into thirds. You split it again, it makes it into fourths. Capital Q is how you get back to having that one window occupy your full terminal session. All the other windows get pushed to the background, and you can split and bring them back up again if you want. Capital A is how you give a new window a name, like it's the server you logged into, or it's the command you're running that you want to come back to. And the history buffer. This is really the important part. This is the part that comes back to tcpdump. When you're watching the flood come through, and you don't want to hit Control C to cancel the tcpdump. You want to leave it running. What you want to do is you want to get into the screen history buffer, and that command is Control A, escape. That flashes, and that's going to show you the buffer. Now, if you hit Control B, that will take you back one page. Control B again takes you back and back and back and back and back. Control F is forward, because all the data is above. You run back all the time. Inside that buffer, because, like I said, you may have 10,000 lines of data, and you saw something, some word that's usually not an agent, some text or whatever. If you use question mark, then you can do the reverse search, just like in Vim, and find that data. And as I said, if you've got 10,000 lines to go through, you should be able to find it, and if it is a real signature, it's a real problem, it should be in there again. And that's how you can narrow it down to writing a signature that you want to put in snort or something like that. With screen, when you're on the command line, if you want to see what sessions are open, because as I said, sometimes when you start it the first time, you wind up running screen, and then you wind up running screen, and you don't really realize how many sessions you have open. You just do dash list, and it will tell you. And if you've been disconnected and you're coming back to it, and the screen's running there on your server, what you want to run is screen dash R. That's for reattach. The D says to detach anyone else that was running that was attached to the screen. So, for instance, if your VPN drops, screen is going to sit there locked saying he had a session. The session's not active anymore, so I'm just going to wait a little bit in case this section reactivates. If you just log back in, if you do dash R, it'll say the screen's already attached, you can't attach to it. So if you say D, R, then it will detach the other TTY session that was previously there and give it to you. If you're running multi-user on, then what you want to do is screen dash X. It'll allow you to attach crossways, attach multiple terminal sessions to the same thing. Okay, that was pretty much my presentation. I can sit here and demonstrate any of the commands, or is there any questions I can answer?
Yeah, I got, it's not really a question, it's just some general use of screen that I've used it for. So if you take the command, just type in screen, and space, and then like your tcpdump command will actually start that up on a new screen. You need to kick it off into the background real quick.
Yeah. Yeah, you can script a lot of it to interact with the other stuff like anything else.
Right.
Some more questions?
I use bash history file a lot to follow what I've done in the past. I go back to that. I noticed if you have multiple terminal sessions open, you'll lose some of those commands in the older history. If there's a way to screen that it follows your command history, how that affects your bash history file.
All right. So his question was about the bash history file and how screen doesn't always throw everything into that history file itself. That's been a problem for me also. The way I get around it is never closing the screen session. For instance, there may be one server that I log into, and it may be a server that just collects logs, and I may want to tail some logs or grab some logs or something like that. And they may be in some esoteric directories that I don't really want to keep up, so something like the history file is exactly what I want. What I use Screen for is I'll have a window just for that server, or even just for that command. For instance, just editing snort rules, and then saving, and then restarting snort, and doing all that stuff. I would have one window that only does that. So if I hit up 3 times, then I'm going to be in there. If I type history inside that screen window, it'll give you the history for that window. If you go to the bash history file, in some installs it's there, in some installs it's not, and a lot of times it's not. But for each window, the history is inside that particular screen window command buffer. Anybody else? Okay. Great. Thank you.